Good afternoon, everyone. As we move into question 3, which deals with transformation, angles, and trigonometry, right? We will be doing a range of questions that will be able to prepare you for question 3. Now, question 3 deals with transformations, namely reflection, rotation, enlargement, and translation. We are expected to know about the angle properties, and we are expected to know about Pythagoras' theorem and be able to apply it. So note, this afternoon is very condensed. You all have some video links. So when you all click on the link, it is supposed...
Where exactly are we finding? Where exactly are we finding the notes?
So the links for today's class, right? When you click on the links, just be mindful that you're supposed to be able to click on the links, and that will take you straight to the specific videos. So we're going to start off with some very basic angle properties. I plan to do transformation and translation and rotations with you so you get a better understanding. And as I said before, if we could pick up marks in every single question, it will go a long way till and for your final grade, right? So let us begin.
Importantly though, we only use these rules in one specific scenario, which is where we have two parallel lines running alongside each other like this, and then another line, which we can call a transversal, cutting through them both. Whenever this happens, we end up with two groups of angles, one here at the bottom and another one here at the top. And there are four important points that you want to notice about these angles. The first is that both groups of angles are both exactly the same. For example, in this case, they both have a 120 degree, a 60 degree, another 120 degree, and another 60 degree angle. The second point is that each group only contains two different angles. In this case, 60 degree angles and 120 degree angles. The third point is that the two different angles will always add up to 180 degrees. For example here, where our angles are 60 degrees and 120 degrees, these two add up to 180 degrees. And the last point is that vertically opposite angles are always the same. For example, these two 60 degree angles are considered vertically opposite, which is why they're both 60 degrees. And likewise, these two 120 degree angles are also vertically opposite. Now, as long as you properly understand all of these rules, you can use this knowledge to work out unknown angles if one of them is missing. For example, if we had to find this angle here, marked x, we'd be able to tell that it's 60 degrees, either because it's opposite this 60 degree angle, and we know that vertically opposite angles are always equal, or because we know that it has to add to this 120 degrees to make 180. To help with more complicated questions though, there are three more rules that are worth memorizing. The first rule is that alternate angles are the same. And what I mean by alternate angles is the two angles found in the corners of a Z shape like this. For example, if we look at our diagram, we can see that the Z shape is here, even though it's been flipped around in this case. And so it's these two 60-degree angles that we consider alternate angles. The second rule is pretty similar, but says that corresponding angles are the same. and corresponding angles are these two angles that you find in an F shape. For example, on our diagram, the F shape is here. So these two 60-degree angles are corresponding angles. The third rule is that allied angles add up to 180 degrees, and allied angles are just the interior angles of a C shape. So in this diagram, these two angles would add together to make 180 degrees. We also sometimes call these co-interior angles, or just interior angles. So just know that allied, co-interior, and interior all mean the same thing here. If we look on our main diagram, we can see one of these C shapes here. So the allied angles would be this 60 degrees and this 120 degrees, which indeed do add together to make 180. One thing to point out with all of these rules is that you'll sometimes see them in other orientations, like flipped around, in which case they'll be harder to spot. But as long as they have the same combination of two parallel lines and one transversal, then the rules are going to be the same. To see how it all works in practice, let's have a go at this exam question. So in this question, we have a pair of parallel lines, AB and CD, and then a transversal that cuts through the two of them. And we need to find the missing angles X and Y. Now, because of all of the different rules that we can use, there are normally multiple ways that we can do questions like this, and so there's no one correct way of doing it. The way I would do it, though, is notice that this section here is like a backwards C shape, and so the 135 degrees and the X are allied or co-interior angles, which means that they must add together to make 180 degrees. So we now know that 135 plus X equals 180, which means that X is 45 degrees. And then because Y is vertically opposite X, we know that Y must be 45 degrees as well. Anyway, that's the end of this video. So like always, if you want to practice questions on any of this stuff, then head over to our platform. If you want to go to this particular lesson,
So looking at the angle properties, let's say that you want to look at the video again, you click on the link and it will open in Safari. So the links are there to help you understand the theory. Now I took the liberty of putting all the properties that you are required to know, right? The corresponding alternate and co-interior. Now, just as he said, and we want to emphasize, vertically opposite angles are formed by an X. So if you see vertically opposite angles, they are equal, and we identify them with an X shape. So in my diagram here, A is vertically opposite to D. So those angles are the same. Corresponding angles are recognized by an F shape. So this angle here corresponds to this angle here. And in my diagram, I could show you the F shape. This is a F, so angle D is equal to angle H. Alternate angles are denoted by a Z shape. So this is the letter Z. Angle C is equal to angle F. And the last but not least, co-interior angles are denoted by a U. So this is a U. So it means that D and F sum to give 180 degrees. Now we are expected to be familiar with at least these four angle properties. So when you get the note for today, please ensure that you look at the video and you learn the 4 angle properties. It will go a long way in answering the question. Now, question 3 deals with angle properties, right? So we will do them by topic. This is the May-June 2024. And whatever marks we pick up in between, it will go a long way towards our final grade. Remember, we are trying our best to do as many topics so that you all could get a better understanding of the past papers. We want to find the value of x. Now, these are parallel lines. How do I know it is parallel lines? Because I have the arrows here. So we want to find x. So x is vertically opposite to this angle here. So it means if I find this angle here, I will be able to find x. So this should be 2 marks, right? So sure you could see a z there, right? So I will use a different color. This is a z. And I just told you Z shape represents alternate angles. So if this is 28 degrees, here will also be 28 degrees. So I have part of my answer, and alternate angles are equal. So here we have 28 degrees, but I'm not finished as yet. I still have to find this missing part here in purple. But the question told me that LRT is an isosceles. So part of the rules for an isosceles triangle is that they have 2 sides equal and 2 angles equal. So if LRT is an isosceles triangle, it means that I could find the missing angle there at L. So L, T, and R. So this is 28 degrees. This side is equal to this side. So I could find the missing angle. So let's work it out. 180 degrees subtract 28 degrees. When you get that answer, you divide it by 2. Go ahead.
In this video, let's talk about
All right, so 152 divided by 2 is 76 degrees. So here I could find the value of x. X is this entire angle here that I could highlight in orange, and it is vertically opposite. So x is 76 plus 28. Go ahead and add it. So once you added the numbers correctly, you are supposed to get 104 degrees. So the 2 marks was within our grasp, within our reach, right? Each exterior angle of a regular polygon is 160 degrees. Calculate the number of sides of the polygon.
For example, these shapes here are all polygons. You can see they're made with straight sides, and the shapes are closed. These two shapes here are not polygons because they're not closed. You can see we have some gaps here. These two shapes are not polygons either because some of their sides are curved. We can split polygons into two categories. We have polygons that we call regular polygons and also irregular polygons. These polygons are regular. What makes them regular is that all of their sides are equal in length. And additionally, all of the interior angles are equal in size. If either of these statements are not true, then the polygon would be irregular. For example, this rectangle here, all of the interior angles are equal, but the sides are clearly not equal in length. This rhombus here, all of the sides are equal in length, but the interior angles are not equal. And for these two polygons here, the interior angles are not equal, and nor are the sides equal in length. If we have a regular polygon with 3 sides, we call this an equilateral triangle. If we extend it to a regular polygon with 4 sides, then this is a square. If we add a 5th side, then this one would be a regular pentagon. If we add a 6th side, this one would be a regular hexagon. A 7th side means we end up with a regular heptagon. An 8th side, now we have a regular octagon. If we add a 9th side, we have a regular nonagon. And if we go up to a 10th side, we have a regular decagon. For your exams, you need to recognize and learn the names of all of these apart from a 7 and a 9-sided shape. So you don't need to know the regular heptagon or the regular nonagon, but you do need to know all of the other ones. This doesn't mean they won't come up in questions, but if they do, they'll probably be named for you. You may already know that the angles inside a triangle add up to make 180 degrees.
You are expected to know that, You are expected to know that the sum of the interior angles in a triangle is 180 degrees.
You may also know that the angles inside a 4-sided shape, a quadrilateral, add up to 360.
Because a 4-sided shape is like a square, like a rectangle, and the sum of those angles is 360.
But many people don't know why. The reason it's 360 is we can split a quadrilateral into 2 triangles like this. Each of the angles in these triangles will add up to 180 degrees. So we have 2 lots of 180 degrees, which is 360. We can extend this idea to shapes with any number of sides. So if we increase the number of sides again and look at the angles inside a pentagon, we can split the pentagon into 3 triangles like this. Each of those triangles will have 180 degrees in them. So this time we have 3 lots of 180 degrees. 3 times 180 is 540. So this means the angles inside a pentagon add up to 540 degrees. Let's do another side and go for a hexagon. This time we can split the shape into 4 triangles. Each of those will have 180 degrees in them, and then if we add up all of those 180 degrees, we get 720. So the angles inside a hexagon add up to 720 degrees. So the first shape, the triangle, had 3 sides. And it might seem a little odd to say this, but it was one triangle. The second shape was a quadrilateral which had 4 sides, and we split that one into 2 triangles. The pentagon had 5 sides, and we split that into 3 triangles. The hexagon had 6 sides, and we split that into 4 triangles. Notice how the number of triangles is always 2 less than the number of sides. So for the triangle, it had 3 sides, and if you subtract 2 from this, you get 1 triangle. The quadrilateral had 4 sides, and if you subtract 2 from that, you get 2 triangles. The pentagon had 5 sides, if you subtract 2, you get 3 triangles. And the hexagon had 6 sides, and if you subtract 2, you get 4 triangles. So the number of triangles we can split a shape into is always 2 less than the number of sides it has. We can extend this now to look at shapes with any number of sides. For example, this shape here. Now if we use our original strategy and split this into triangles by drawing them, this one gets quite messy. There are loads of triangles. Instead, we can just count up the number of sides. This shape has 15 sides. If we subtract 2 from this, we know without drawing them, there must be 13 triangles. Each of those triangles will have 180 degrees in them, so we do 13 multiplied by 180, which gives you 2,340. So all of the angles in this 15-sided shape must add up to 2,340. We have a special name for this total. It's known as the interior angle sum, because it's the sum of all of the angles on the inside of the shape. We can create a formula for this based on what we've looked at so far. Let's say that we have a shape with n sides. To find the number of triangles, we subtract 2 from the number of sides. So this is n subtract 2. And then once we have this number of triangles, we just multiplied it by 180. So this formula here will allow you to work out the interior angle sum of any polygon of any number of sides. Let's have a look at how we can do this in some questions. So for the first question, we're going to work out the interior angle sum of a decagon. Earlier we said a decagon had 10 sides. So using this formula, we want to do 10 subtract 2, so 10 becomes the n, and then multiply this by 180. If you do this with a calculator, you end up with 1,440. Or we could work out the interior angle sum of a polygon with 24 sides. So all we do is replace the n in the formula with 24, so it's 24 subtract 2 multiplied by 180, and this gives you 3,960. Sometimes exam questions may require us to work out the interior angle sum. For example, this question here. For this question, we're looking to find the angle x. We can see that this shape is a pentagon since it has 5 sides. We can work out the interior angle sum of the pentagon using the formula. Let's replace the n in the formula with a 5. So it's 5 subtract 2 multiplied by 180, which gives you 540. This means all of the angles on the inside of that pentagon must add up to make 540 degrees. Now I can see 3 of them, and we also have one in the top right which is a right angle, and a right angle is 90 degrees. If we add up the 4 angles that we have, 95, 121, 90 and 104, we get a total of 410. But we know that all 5 of the angles must add up to make 540. So if we subtract this 410 from 540, we'll find the remaining angle. 540 subtract 410 is 130. So the size of angle x must be 130 degrees. Now let's try another example like this, but slightly more complicated. So we've got this irregular polygon here, and we're told that angle ABC is 3 times angle BCD. And we've been asked to find the size of angle ABC. So angle ABC is this one, and angle BCD is this one. Let's call angle BCD x. Now since angle ABC is 3 lots of angle BCD, it's 3 lots of x, and 3 lots of x is 3x. Next we want to work out the interior angle sum. This shape has 6 sides, so we need to do 6 subtract 2 multiplied by 180, which will give you 720. This means all 6 of these angles must add up to give 720 degrees. So let's add up all of the angles. Now this time 2 of the angles
So here I have included a note for you. They have 180 into n minus 2, which is the same as 2n minus 4, right? And sometimes we are required to find the sum of the interior angles. Now I have a general summary table listed: triangles 180, quadrilateral 360, pentagon 540, hexagon 720, heptagon 900, octagon 1080. Sometimes we are expected to find the number of sides. And this question was taken from one of the CXC booklets. And the question says, find the measure of the exterior angle of a regular polygon is 45 degrees. How many sides does this polygon have? So to find the number of sides, we divide 360 by 45 to get 8. Now this is taken from the CXC booklet, and let's take a look at this question. Each interior angle of a regular polygon is 160. So if we have a regular polygon and the interior angle is 160 degrees, then the exterior angle would be 180 minus 160. 180 minus 160 is 20 degrees. So the number of sides will be 360 degrees divided by 20 degrees. Work that out and you will be able to find the number of sides. The degrees will cancel and 20 could go into 360 18 times. So the polygon has 18 sides. So just be mindful that if you are given the interior angle, then to find the exterior angle, you take it away from 180. 180 minus, right? 160, and that will give us 20 degrees. To find the number of sides, you need to divide the angle by 360 and you will get your answer. In addition to that, here we have a triangle that is lodged somewhere in a circle. Now, doing circle theorems, we know that the angle in a semicircle is a right angle. So if the angle in a semicircle is a right angle, then ABC is a right angle triangle. They are asking for the geometrical name of AB. Now, the options that you have for AB are radius, chord, diameter. Now, the radius and the diameter pass through the center. That line AB doesn't pass through the center. So AB is the chord. They ask you to find the value of the radius of the circle. So here, this is the diameter, and it is also the hypotenuse. So I could draw this as a right triangle. And my options, because it is a right triangle, I can label here B. This is my right angle. This is C, and this is A. BC is 8.2, and AB is also 8.2. I want to find the hypotenuse. It is a right triangle, so I am going to incorporate Pythagoras' theorem. So in a nutshell, very quickly, let us look at the application of Pythagoras' theorem.
To find the value of x in this example, notice that we have a right triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared, where a and b are the lengths of the legs of the right triangle and c is the length of the hypotenuse. So here, since the legs of the right triangle have lengths 6 and 8, and the hypotenuse has a length of x, we can set up the equation 6 squared plus 8 squared equals x squared. Simplifying from here, 6 squared is 6 times 6, or 36, and 8 squared is 8 times 8, or 64. So we have 36 plus 64 equals x squared. Next, 36 plus 64 is 100, and we have 100 equals x squared. Now to get x by itself, since x is squared, we take the square root of both sides of the equation. On the right, the square root of x squared is x. And on the left, since 100 is the perfect square 10 times 10, the square root of 100 is 10. So 10 equals x. Notice that we don't use plus or minus 10 because x represents the length of the hypotenuse of the triangle, which cannot be negative. So the value of x is 10.
Now, let us just observe what she did here. From observation, we recognize that the longest side of the triangle is x. So if the longest side of the triangle is x, she squared 6 and she squared 8 and she added those numbers. So 6 squared is 36, 8 squared is 64. The sum of 36 and 64 is 100. And the square root of 100 is 10. So we're going to apply that same concept in our past paper question to find the value of the hypotenuse. All right, so we want to find the long side. So if I label here C, B, A, C squared is equal to 8.2 squared plus 8.2 squared. Work out that for me using your calculator. When you find the answer and you add it up, find the square root. So 8.2 squared is 67.24 and 67.24 multiplied by itself is 134.48. So C is the square root of 134.48. You are required to find the length of the radius, right? Notice this is 3 marks and they're asking for radius. So C is equal to 11.596 and this is the length of the diameter. So the radius will be 11.596 divided by 2. All right, so this is 5.80 centimeters. So what they are asking is that you are required to use Pythagoras' theorem. So the correct application of Pythagoras' theorem will award you 1 mark. Once you find the diameter to be 11.56, you will get the 2nd mark. And the 3rd mark is coming from finding the correct value of the radius. All right, so we move it along. A vertical flagpole stands on horizontal ground and is held by 2 ropes, PG and PR, as shown in the diagram. Calculate the height of the flagpole FP. To work out the height of the flagpole, we don't have enough information that will allow us to use Pythagoras' theorem. Yes, it is a right triangle. So if not Pythagoras' theorem, then what else? What are our options?
In today's video, we're going to look at how we can find unknown angles or sides in right-angled triangles. The first thing you need to know is that you can normally tell when a triangle is a right-angled triangle because it will have this little square in one of the corners, which tells us that it's 90 degrees, so a right angle. The second thing to know is that this side opposite the right angle is always called the hypotenuse, which we represent with the letter H, and this will always be the longest of the three sides. Now, how we label the other two sides changes depending on which angle we're interested in finding. For example, if we were interested in finding this angle in the bottom right, which we'd label as x, then this side, which is opposite to x, would be called the opposite, which we represent with the letter O. And then this side next to our x angle, or in other words, adjacent to it, would be called the adjacent. So we label it with the letter A. On the other hand, if we had this other triangle, and we were interested in finding this top angle instead, then the longest side will still be the hypotenuse, as always, but this bottom side would be the opposite, O, because it's opposite the angle we're trying to find. And then this left side would be the adjacent.
All right, so let me make it not confusing, right? In a right triangle, our options are Pythagoras' theorem or SOHCAHTOA. I am almost certain that you all heard those terms already. I already mentioned we don't have enough information to use Pythagoras' theorem. So my next option is SOHCAHTOA. How do I know which trig ratio am I going to use? Now, first things first, the side opposite the right angle is called the hypotenuse. And this is the longest side of a triangle. The angle X tells me which is the opposite side. I am opposite to you. So X is opposite to this side here. So if I label longest opposite, the third side must be the adjacent. And for the trig ratios, so ka toa, whatever information is given in the question directs me into which trig ratios to use. So if I have opposite and hypotenuse, I use sine. If I have adjacent and hypotenuse, I use cosine. And if I have the opposite and adjacent, I use tan. So it is not rocket science for you to determine which one to use. You must know that there's a right angle. If there is a right angle, the side opposite the right angle is the longest side, called the hypotenuse. If there is an angle, then the side opposite the angle is called the opposite side. And last but not least, the third side is the adjacent.
Now, to help us work out the unknown angles and sides, we're going to be using three different equations. Sine x equals opposite over hypotenuse. Cos or cosine x equals adjacent over hypotenuse. And tan equals opposite over adjacent. Unfortunately, you have to remember all of these off by heart. But what's easier is just to remember the phrase SOHCAHTOA. And then you can work out the equations from that. For example, if we look at SO, the S stands for sine x, the O stands for opposite, and the H stands for hypotenuse. So we know that sine x equals opposite over hypotenuse. Meanwhile, for ka, The C stands for cos or cosine x, the A stands for adjacent, and H stands for hypotenuse. And the same rules apply to TOA. T for tan, O for opposite, and A for adjacent. If it helps, you can write SOHCAHTOA as S equals O over H, C equals A over H, and T equals O over A, which makes it a bit easier to spot the equations. To see how these equations work in practice though, let's have a look at this question, where we've got to work out the value of the unknown angle x. Now, numbers, and of x, and then dividing both sides by cos x.
What I would like you to do, this is taken from the 2024, May-June 2024. I would like you to draw the triangle before we start doing it. So quickly, it won't take you long. If you have the booklet and the question isn't done, you could use it. But if you have the booklet and the question is answered, please don't use it. It wouldn't benefit you at all. If you have the booklet and the question is unanswered, it's all fine and well. The first thing we're going to do, we're going to calculate the height of the flagpole. So just to make life simple, I'm going to redraw the triangle. I am going to identify my right angle. I'm going to label here P, label here F, label here G. This is 38 degrees, and here is 18 meters. I have two sides. I have the longest side, which is called the hypotenuse, and I have the opposite side. So in your diagram, I would like you to label the opposite side for me, which is opposite the angle, and the hypotenuse, which is opposite the right angle. So you are supposed to label PF opposite because that is the opposite side to the angle. And the opposite side to the right angle is the hypotenuse. So I am just going to list out my options. And seeing that I have O and A, O and H, I'm going to use sine. So sine of 38 degrees is equal to the opposite over the hypotenuse. So sine of 38 degrees is equal to FP over 18. Now this is a fraction. I want to remove the fraction. How do I remove the fraction? By multiplying both sides by 18. So I will get FP is 18 multiplied by sine 38. Work out that for me. All right, so FP is equal to 11.08 meters. That is the answer you're supposed to get, right? For 2 marks, once you use the ratio correctly, you should have gotten those 2 marks. So this is 11.08 meters. The next part of the question is to find PR. Now, in a straight line, we have angles that give us 180. So this is 180 degrees. So if it is 180 degrees, and I know the length of this line, and I know the length of this line, I could use Pythagoras' theorem. So let me use Pythagoras' theorem to find the length of the flagpole. So this is C, this is A, and this is B. So C squared is 11.08 squared plus 9.7 squared. Square the numbers, add it, and find the square root. Go ahead. Find the square root and write your answer to 2 decimal places. So this is 14.725, which is approximately 14.73 meters. If you had used as well 216.96, you will get 14.73 as well. So even if you approximated the number, you will have still gotten the 14.73. Now CXC not going to penalize you. They did not tell you to put it to 2 decimal places. So if you all put 14.7, you will still get the mark. They're not going to penalize you for 1 decimal place. They would not do that. All right. So we want to look at this last question, and then all the fun will start. We're going to do transformations, translations, rotations. That is the fun stuff, right? So we have an hour to do that. All right. So this is July or May, June 2021. The question says the diagram below shows a triangle, and right away you're seeing angles. So you're supposed to be thinking sum of angles in a triangle is calculate the size of this angle. So I am leaving it up to you to take a minute or two to work out the size of the angle. All right, so the sum of angles in a triangle is 180 degrees. So 180 minus 62 minus 90 degrees is your answer. This is 28 degrees. All right, 28 degrees for 1 mark. Really and truly, that wasn't bad at all. All right, then we have the length RQ. Now we don't have all the information that will allow us to use Pythagoras' theorem. So our next option is SOHCAHTOA. So I will redraw the triangle so that you will understand what the information I am using to find the length. So I will use the 28 degrees, or I could use the 62 degrees. This is my opposite side, and this is my hypotenuse. So I want to find RQ. So according to this, if I have the hypotenuse and the opposite side, because it is the opposite angle, I can use sine. So sine 62 is equal to RQ over 11. It is a fraction. I want to get rid of the fraction. I need to multiply by the denominator. RQ is 11 sine 62. Work it out. You are supposed to get 9.71 centimeters for 2 marks. So even if we did question 3 and we get 3 marks, well, all fine and well, that will give us a better chance of scoring a better grade, right? We're trying to capture all the marks possible. Right, so this is where the fun going to start. We're going to do reflections, translations, rotations, enlargement. And I'm sure that you're all supposed to be able to capture some marks here.
Let's try with assigning this triangle here in this line. We give this line a name and it's called the mirror line. If we reflected this triangle in this mirror line, the triangle would flip over the mirror line and create a reflection that looks like this.
Now, we are accustomed to reflections on a daily basis. Every day, before we leave home, we stand in front of the mirror before leaving home to make sure that we are looking presentable before leaving home. So the object, which is us, is reflected the same distance behind the mirror, right? And that is called the image.
If we move the original triangle up or down the mirror line, its reflection will follow. If we move the original triangle away from the mirror line, its reflection will also move away from the mirror line the same distance. So the original shape and the reflection are always the same distance away from the mirror line. This applies to all of the points on the shape. The original shape is known as the object. This is the one that's going to be reflected. The one that has been reflected is known as the image.
So let me pause there a little bit. And I want you to take note of the number of spaces the object is in front of the mirror. So we have 1 block, 2, 3, 4, 5. Now, my image is going to be reflected 1, 2, 3, 4, 5. That is where they got the mirror line. So the distance from the object to the mirror line is the same distance from the image to the mirror line. And I want you to remember that. Huh?
Let's have a look at how we could reflect this shape here. I would reflect a shape by doing it one corner at a time. We're going to start with the corner at the bottom. This corner is only 1 square away from the mirror line. This means its reflection will also be 1 square away from the mirror line, but on the other side. The corner at the top is 2 squares away from the mirror line, so its reflection will also be 2 squares away from the mirror line. And the remaining corner is 1, 2, 3, 4 squares away from the mirror line, so its reflection should be 1, 2, 3, 4 squares away from the mirror line as well. So if we reflected this triangle, it would look like this. Let's try with a second shape. This time, this shape is actually touching the mirror line. The point that's actually on the mirror line doesn't need to be reflected at all. That will stay in the same place, but we do need to do the other 3. Let's start with the one at the top. This one is 2 squares away from the mirror line, so we go 2 squares past the mirror line. The one in the bottom right is also 2 squares from the mirror line, so we go 2 squares past the mirror line. And the one in the bottom left is 5 squares to the mirror line, so we go 5 squares past the mirror line. And the reflected shape will end up like this. Now sometimes the mirror line might be horizontal rather than vertical. Let's try this example. So we'll do this one corner at a time as well. Starting with the one on the right hand side, this is 1 square from the mirror line, so we go 1 square past it. The one in the bottom left is also 1 square, so we go 1 square. The one in the top right is 3 squares away, so we go 3 squares past it. And the one in the top left is also 3 squares, so 3 squares past it. And the reflected shape would look like this. Now sometimes the mirror line isn't vertical or horizontal at all. It could also be a diagonal line that looks like this. Let's reflect this triangle in this diagonal mirror line. We will still do this one corner at a time, but there is a slight difference in the method. Let's start with the point in the top right corner. If we go horizontally, this one's 1, 2, 3 squares to the line. But we don't continue 3 squares in this direction. Instead, we imagine that when we hit the line, we take a 90-degree turn and go 3 squares down instead. So we'll need to go 1, 2, 3. Let's try this with the other points. So this time we'll do the one in the bottom left. That's 1, 2, 3, 4 to the mirror line, but then we're going to go 4 down. So 1, 2, 3, 4. Now we'll do the final point. This one's quite far from the mirror line. 1, 2, 3, 4, 5, 6 squares. So we'll go 1, 2, 3, 4, 5, 6 squares. So this is where the reflected triangle will be.
So let us look at that. That is a reflection. You can clearly see that it is a reflection, right? Look at how it is, and that is a reflection in the line y equal to x. I want you to remember that, that is a reflection in the line y equal to x. So for your use, you have different reflections here, but this one I want to point out. This is a reflection, right? And look at how it looks. So this one is a somewhat popular one that CXC tends to bring from time to time. And yes, it is a reflection, right? And look how the object and the image looks, right? So we're going at this one. So this is not just looking at it. The distance between here and the distance, this one, so if you notice, this is a reflection. T is being reflected on Q. And this is my line of reflection. So describe fully the transformation. So CXC is looking for two things. You see it's 2 marks. So you have to write 2 reasons to get the mark. It is a reflection. Just by you writing a reflection, CXC will give you 1 mark. And the reflection in what? The line y equal to x. And you're probably asking, well, what is the line y equal to x? The line y equal to x just shows that x and y has the same value. So let me show you. Here x is 1, y is 1. Here x is 2, y is 2. This is 1 point. This point here, x is 3, y is 3. Here, x is 4, y is 4. This is the line y equal to x. This point here, x is 5, y is 5. This point here, x is 6, y is 6. X is 7, y is 7. X is 8, y is 8. So this is the line y equal to x. So to get 2 marks in this question, you have to state a reflection and you have to state y equal to x. Let us say for some reason you didn't know that it was y equal to x, but you knew it was a reflection. Well, write that. Write reflection alone and you'll get the mark, right? The next part is to draw the image of the shape that undergoes a translation. A translation, let me break it down simple. I could ask you to stand, and I could tell you to move to your right, 3 foot spaces. I could also tell you to come forward or come backward, and that is a translation. I never ask you to turn. So a translation doesn't turn. It moves along the X and the Y. So if you move along the positive X-axis, it's positive. If you move along the negative X-axis, it's negative. If you move upward, it's positive. Downward, it's negative. So a translation, as we see here, is the next one that we're going to do. So we get in there. Slowly but surely, we're beginning to understand and appreciate the different types of transformations.
We call the image, and in maths, a translation describes a movement from one place to another. For example, if we had this shape here, and we moved it over to here, we could say that this shape has been translated.
Notice the shape didn't change orientation. It just slid. It slid from one point to the other.
To help us describe translations, we use vectors, which look like this. The top number of a vector will tell us how far to move left or right, and the bottom number will tell us how far to move up or down. If the top number is positive, it tells us to move to the right. If the top number is negative, it tells us to move left. If the bottom number is positive, it tells us to move up. And if the bottom number is negative, it tells us to move down. In this vector, for example, both of the numbers are positive. So the 3 tells us to move 3 to the right, and the 5 tells us to move 5 up. To help you remember which directions the vector is describing, I like to use a coordinate axis. When we draw out a coordinate axis, we put the positive numbers towards the right and in an upwards direction. This might help you remember that positive means right and positive means up. And when we draw the negative numbers, they're over on the left and in the downwards direction. So this may help you remember that negative means to the left and negative means down.
You don't even have to remember that. If you know how the Cartesian plane works, let me show you. These are positive numbers. These numbers are positive, right? So we move in a positive direction. And this is X. If we move into the left, these are negative, and this is also X. Moving up is positive, and this is Y. And moving down is negative, and this is Y as well. So if I tell you move 3, 5, you're moving right and up. If I tell you move -3, -5, you're moving left and down.
Let's have a look at some different vectors. We already said that this one was 3 to the right and 5 up. But what about this vector here? So the top number tells us to move left or right, and since this one's negative, it will mean left. So this -2 means 2 to the left. The bottom number tells us to move up or down, and it's negative, so this means down. So this is 3 down. So this vector would tell you to move a shape 2 to the left and 3 down. And this vector here? Well, the top number's positive, so this means to the right, so 5 right, but the bottom number's negative, so this means 1 down. And for this vector here, the top number is negative, so this is 8 to the left, and the bottom number is positive, so 3 up. And we'll have a quick look at 2 more vectors. So this one here, which is 0, 4. Since the top number is 0, we don't need to move left or right at all, so we only need to consider movement up or down. The bottom number is positive, so this one means to go 4 up. And for this vector here, -1, 0, -1 on the top means to go 1 to the left, and the 0 on the bottom means we don't need to move up or down at all, so this vector is just 1 to the left. Now let's have a look at how we can use vectors to help us do translations of shapes. In this question, we could be asked to translate the shape A by the vector 3, -4. This vector means 3 to the right and 4 down. So that's where we're going to move the shape. 1, 2, 3 to the right, and 1, 2, 3, 4 down. So the final shape would end up here if we've done this translation. Now I'm able to move the shape around on a computer quite.
So I feel you get the gist of it here. Let me go back to the question. So the question asks to translate t -1/6. So the translation is -1/6. So I'll give you a couple minutes to do it. If you don't have the past paper book, you could draw the grid. It's all fine and well. The thing about it is we need to practice it. So I'll give you a couple minutes. And what I want you to draw is T. And T has 5 vertices. So we're moving along the x-axis, 1 space, right, to the left. And we're moving upward 6 spaces. So we move in 1 space to the left. So this is 1 vertex, 2, 3, 4. So you're moving 1 space. So this is the new position. And then we move in 1, 2, 3, 4, 5, 6. So this will be my new position. Go ahead and move all these spaces there and see how best you can draw it. So we move in 1 space to the left, and we move in 6 spaces up. So you're moving all the points like that. 1 space to the left and 6 spaces up. So we're going to translate T up here. Go ahead. All right, so the next point, I'm going to move 1 space to the left, 1, 2, 3, 4, 5, 6. This will be my next point. Then 1 space to the left, 1, 2, 3, 4, 5, 6. Right? And I have 1 point again. 1, 2, 3, 4, 5, 6. So this is my new image. And we will call this M. So I do hope that you were able to draw that. And you notice with the transformations, reflections, and the translation, it is pretty easy to get a mark or two here and there, right? So we would have completed the entire question here. I'll just leave that up in case you want to look at it. And we have some others to do. So we're going on to 2023, I believe. So let's go. What I would like you to do, this is my object. If you don't have the question, I would like you to draw the graph and you're reflecting this in the line x equal to -1. So you're going to find -1, and this is the x-axis here. And you're going to find -1, and this is the line. So it is a vertical line passing through x equal to -1. So I want you to take a few minutes and draw the reflection of that shape. How would it look when it is reflected in the line x equal to -1? Remember, it's a reflection, so you will see it somewhere here. Go ahead and do it. All right, so by now, you're supposed to draw it. So let us just count. We have 2 spaces here to the line, so we have 2 spaces behind. So this is my first point. Then here we have 1, 2, 3 spaces, 1, 2, 3. So the shape is finally coming together a little bit. Then I could count here 1, 2, 3, 4, 1, 2, 3, 4. And then the last one, 1, 2, 3, 4, 1, 2, 3, 4. So this is my new shape that has been reflected in the line x equal to -1. And they told me to label this A prime. Now, I would like you to translate A, which is this, along the vector 4, -7. So if it is 4, -7, each point is moving to the positive, so it's moving along the right. And if it's going -7, we're coming down. So each point, you're moving it 4 across and -7 down. So I will do the first one for you. So I'm moving this point, 1, 2, 3, 4, and I'm coming 1, 2, 3, 4, 5, 6, 7. So you're doing that for each point until you move all 4 points. I will give you some time. You go ahead and try it. All right, let's see. So I'm moving this point. 1, 2, 3, 4, and I'm coming 1, 2, 3, 4, 5, 6, 7. So this is the next point here. Then I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Right? So that is my third point there. And then the last one, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So I will use red so that you can see it. And this is my new image. And I'm calling this A double prime. So just be mindful, 4 is positive, so you move to the right. 7 is negative, so you move down. Positive, negative. Up is positive, down is negative. This is X and this is Y. So keep that in mind. So we have 2 questions to complete. One is the 2021, so let's go to that. And this is what it looks like. So we have X, we have Y, and we have Z, right? Here we have a rotation. In the rotation, we are required to say a couple things. Right? So let's just start off the question by looking at the video, and then we will go straight into it.
This direction here, which we call clockwise. This is because it follows the same direction as the hands on a clock. Or we could go in the opposite direction, which is this way, and since that's the opposite to the way the hands on a clock move, we call that one anti-clockwise. For this video, we're going to look at rotating a shape by either 90 degrees or 180 degrees. Since one full turn is 360 degrees, 180 degrees will be half a turn, and 90 degrees will be 1/4 of a turn. So if we were to rotate this shape 90 degrees clockwise, it would go 90 degrees, or 1/4 of a turn, in the direction that a clock hand moves, so it would look something like this. Instead, if we were to go 90 degrees anti-clockwise, it would go 1/4 of a turn in the opposite direction, so it would look like this.
And we could do that, eh? So this is my remote here. This could give me a 90 degrees in a clockwise, and I can move it in the reverse anti-clockwise. So this one, clockwise, is how the clock turns. Anti-clockwise is the opposite direction.
180 degrees, we can actually look at both directions at the same time. So for the left shape, we'll do 180 degrees anti-clockwise, and the right one 180 degrees clockwise. And 180 degrees is half a turn. Notice how both of these shapes end up in the same place. This means that when we rotate by 180 degrees, we don't actually need to give a direction at all. We can just say 180 degrees, and lose the clockwise or the anti-clockwise. Sometimes you may be given a shape and asked to rotate it around a particular point. So for this question, it says rotate shape A 180 degrees about the point P. To do a question like this, I'd use a piece of tracing paper. First of all, trace around the shape that you're going to rotate, and then take a pencil and place it firmly onto the point you're rotating around. So we'll place a pencil on the point P here. Then, with this firmly pressed in place, turn your tracing paper the amount of degrees you've been asked to. So for this one, it's 180 degrees, so that's 1/2 a turn. And remember, it doesn't matter if I go clockwise or anti-clockwise for this one. So I'm going to go 1/2 a turn clockwise. When you turn it, you'll find that the final shape needs to end up here. So we lift off the tracing paper and draw the shape here. What about if the question had said to rotate this shape 90 degrees clockwise? Well, we do exactly the same thing. We trace around the shape, Then we take a pencil and place it on the point we're rotating around, but we're going to go 90 degrees clockwise this time, so 1/4 of a turn in the direction that the hands on a clock move. So with the pencil firmly pressed down, we take the tracing paper and turn it 1/4 of a turn in that direction. Your final shape will end up here, so we remove the tracing paper and draw the shape there. And of course, it could have said to rotate it 90 degrees anti-clockwise. Once again, we trace around the shape, place the pencil onto the point P, and then we'll turn it 1/4 of a turn, but anti-clockwise, so in the opposite direction this time.
So sometimes we are asked to find the center of rotation. So let's look at that.
So I'm going to demo how to find the center of rotation. This question is taken from the textbook, page 317, and it's question number 2. So we have the object here, and that's been rotated to the image there. So what we need to do is find the center. Now what you want to do is find 2 corresponding points on the shapes. So if I look at this corner here of the object, I need to find the same corner on the image, which is that one. So I'm going to draw a line between the 2 points there. Now there's a technical way to do this using compasses, but if you want to just have a go, you need to find the middle of that line. So if I just measure it, I can see it's 5 centimeters long, so 2.5 centimeters is there, halfway. So find the halfway point, and I need to draw a perpendicular line to that. Perpendicular, of course, means at 90 degrees. So if I can draw a 90-degree line through there, and that's just about right, and that will set me up to find the center. Right, I need to do that again with another pair of corners. So let's try this top corner here, top left corner there. Where's the same one on the image? So that one will be that one. Oh, that's nice and easy, straight down underneath. So if I measure those two, well, I can see how many squares is that. 1, 2, 3, 4, 5, 6, 7, 8 squares. So halfway will be 1, 2, 3, 4 there. So draw the line, joining them. That point there is halfway between. So let's do a perpendicular line with that, going through there. Now my 2 perpendicular lines that I drew, they meet just about there. So that means that's where my center of rotation is. Coordinates -1, -1. -1, -1.
So
There we are.
where 2 perpendicular lines meet, that is the center of rotation, right? So you may not be able to get all the marks for the different transformations, but we are supposed to be able to pick up some of the marks. So let's look at this. The diagram below shows 3 triangles, X, Y, and Z. Now this is taken from the 2021, so June 21, right? Triangle X is mapped onto triangle Y by reflection. State the equation of the mirror line. So triangle X is mapped onto triangle Y by rotation, by reflection, sorry. State the equation of the line. So in your mathematics booklet, I want you to draw where you think the mirror line should be. You draw the line where you think the mirror line should be. I'll give you a minute or two. So you have X and Y, and it's supposed to be able to draw the mirror line, which is the line where X is reflected onto Y. So go ahead. And if you have this line here, you are indeed correct. But the question never asks you to draw the line. The question asks for the equation. So although I could see it and you could see it, that is the line, right? You need to know what is the equation. And the equation for the x-axis is y equals to 0. Because on the x-axis, we only have values for x. Y is 0 on the x-axis. So this one is y equals to 0. And let me repeat it in case you didn't get it. On the x-axis, we have x values. We have no y values. So for the x-axis, y is 0. Similarly, for the y-axis, x is 0. So that is something that you need to be mindful of, right? The next one is describe the transformation that maps x to z now. So we're not interested in this anymore. We go into this one, x and z. So from observation, we know that it is not a reflection. We know that it is not a translation. So it must be a rotation. So if rotation is all that you can write, please write it. You will get a mark because this is 2 marks. So if rotation is all that you know, please write it. Now, what you could write as well, because you could see we move in this side, so it has to be against the movement of the clock. So if we are moving against the clock, it is an anti-clockwise rotation. So we could write that. You see, all these things, just by looking at it, I can write it. So CXC will award me at least 1 mark. I could clearly see the clock moves in this direction. The clock moves like this from X to Y. But if we move in the opposite direction, it is anti-clockwise. Right. I showed you the last video so that you could see we could get the center of rotation. But if you cannot get the center of rotation, that's it, leave it. We could still get the mark for rotation and anti-clockwise. But I still need to show you how to do it. We need to draw 2 perpendicular bisectors. So I need to draw 2 lines, right? 2 similar lines. So I will use this point and this point. You know how a 90-degree looks, right? So this is the line here that I'm going to draw, and I will wait for you to draw it as well. Draw the line. So that is 1 line. I want you to find the middle of that line. right? So the middle of that line should give you this new line here. So that is one line. So to find the center of rotation, I need to do that again. So if I connect this point and this point, right? And I want to find the middle of that. So I'm going to turn my ruler slanted. I'm going to make my ruler slanted and I'm going to draw a line through there. So where the two lines intersect, here is the center of rotation. So let me revise it. I draw a line connecting 2 points and I draw a 90 degree. How did I get 90 degree? Well, just draw the line straight and then for the next line, I connect a next 2 points here and I draw a 90 degrees. And where the two lines intersect, that is the center of rotation. And that is the point 0, 0. So this is the center of rotation, right? Then they asked me to translate y using the vector -7, 1. So I'm going to use y and I'm going to translate it -7, 1. So this one we could do because we know we get any mark there. So even if we didn't get a mark for the center of rotation, that's fine. We could still move on. So using the vertices of the point, so we move in -7. So therefore we move in to the left. So 1, 2, 3, 4, 5, 6, 7, and we move in one space up. So this is my new point. I will give you a couple minutes for you to do it. We translate in y -7, 1. So go ahead. We're supposed to be able to get a mark. We'll do the next point. -7, 1, 1, 2, 3, 4, 5, 6, 7, 1 up. And I have 1 point again because it is a triangle. 1, 2, 3, 4, 5, 6, 7, 1. So this is my point, and this is how the triangle is supposed to look. And this is represented by image V, right? So I have one part again to do. So I'll give you a couple minutes just to finish on that. And I want to show you how to do the enlargement. All right, so the last part of the question, it says that triangle X is enlarged about the origin on a scale factor 1/2. So if I tell you to go and make a copy of a triangle and make sure it's 1/2, therefore the size is supposed to shrink, right? So here what we do. You're drawing a line from this to 0 and you're finding 1/2. That's the first point. Then you're drawing a line from here to here and you're finding 1/2 of that line. And you're doing the same thing. You're finding 1/2 of those lines and that will be your center your triangle that has been enlarged by a half. So let me do it together. So let me do this one. Starting from the center, I'm drawing it to one vertex here. If I count the distance, this is 1, 2, 3, 4, 5, 6. Half of 6 is 3. So my new point will be here. So go ahead and draw it in your book. That is my first point. All right, the next one, I could draw a line to this vertex now, and let us count. 1, 2, 3, 4. Half of 4 is 2. So this is my second point. So my triangle is coming along. Right? And then the last one, I'm drawing a line from 0 to here, and that is 2. So that means my last point will be here. So my triangle would look like this. This is the triangle, and it has been enlarged by a half, meaning that it is half the size. Look at it. That triangle has been enlarged by a half. So this is half the size of the original. Right, the last one that we're going to look at before we end today is the 2023. 2022. This is what it looks like, right? Did we do any part of this question? No, we didn't do anything. So, this is May, June 2023, right? The question asks, describe the single transformation that maps P onto Q. So if I have something looking like this, and now it's looking in that direction, that is clearly a rotation. So you're supposed to be able to write something. It is a rotation, right? Rotation. The second thing you need to write, whether it's clockwise or anti-clockwise. So it's moving in the direction the clock turns. So this is clockwise. And this is the object. This is 90. It's facing this side. So that is a whole 180 degrees. So this, I would have gotten my 3 marks. So now we're going from P to R. P to R, what type of transformation is that? P to R is clearly a reflection. It is a reflection. I want you to draw. So they're asking, and that is 2 marks. It is a reflection, and they want the line of reflection or the line of symmetry. So go ahead and draw it. Go ahead and draw it from P to R. Where is the line of symmetry? So this is what we're looking at. P here. And we're looking at R. So you could safely see that P to R is a reflection. So the line or the axis of symmetry must be midway between that. So here it must be passing through the line x equal to 1. Right? So it is a reflection. If reflection is all you know, write it. You will still get a mark because reflection is correct. X equal to 1 and then P to S. Now here what? P has gotten bigger and form S. So it can be rotation, it can be translation, and it cannot be reflection. So the only one it has to be is an enlargement. Enlargement meaning it getting big or small. So if that all you know, write it. You'll get a mark. Right. A couple things. How much bigger has it gotten? Could we work out how much bigger it has gotten? Well, this is 4 units. How much units is this? So we could work out the scale factor. How many times did I take P and make S? We could work it out. How many blocks is this line? This is 1, 2, 3, 4. So this is 1, 2, 3, 4, 5, 6, 7, 8. So guess what? The scale factor is 2, and it's just easy like that. 8 divided by 4 is 2. So you could write scale factor 2. So you see again my marks, eh? And the last thing that I could do is I could find the center of enlargement. And here how easy this is. I just go in and take 2 points and I go in and match them up. I'm taking 2 points and I'm matching them up and I'm drawing the line. I'm taking this point and I'm drawing a line. That is 1. Then I'm taking this point and I'm drawing a straight line. And where the 2 lines intersect, this is my center of enlargement. And the coordinates of that point is 7 and 11. So that is my center of enlargement, 7, 11. And having gotten that, I would have scored 3 marks. But even if I just write enlargement alone, CXC going to give me a mark, right? If I just write rotation alone and clockwise, they will give me 2. And if I just write reflection, I will still get a mark. So you see, question 3 isn't all hope lost, you know. There are still things in question 3 that we could score at least 4 or 5 marks. And let us look at this last part here. On the grid, draw the image -2, 3. So that's the last thing we're going to do, -2, 3. So P, we're going to draw P and it's going -2, 3. What does that mean? It means that it's going to my left 2 and 3 up. So 1, 2, 1, 2, 3. So I know if it's anything again correct, it's a translation. Eh? Then 1, 2, 1, 2, 3. Right? So it's coming along. Then I have this point 1, 2, 1, 2, 3. Right? So I could erase all this because I could see the shape forming. This is my shape. Right? Something like that. And having drawn that, this is -2, 3. I'm moving to the left 2 spaces and I'm moving up 3 spaces. So you see, with the transformation question and with question 3, I could still grasp 1 or 2, even 3, even 5 marks, depending on what they get. So what I am teaching you over the next couple of days is in each question, we should be able to get some marks. So there is one.
Rotation. Translation. There are 3 basic transformations that can be done to a shape: reflection, rotation, translation. These transformations move the shape without making any changes to its shape or size. Reflection.
So the only one that makes a change to the shape or the size is the enlargement, right?
A reflection flips a shape over to create a mirror image. In this example, the triangle on the right has been reflected, flipped over the dotted line to create a mirror image. Or we can say that the vertices of the triangle A, B, and C has been reflected, flipped, over the dotted line to create the mirror image as another triangle having vertices A dash, B dash, and C dash. Rotation. A rotation turns a shape. In this example, the triangle has been turned or rotated. Sometimes shapes are rotated just a few degrees, and other times they may be rotated significantly. A translation moves or slides a shape.